We're going to talk about sequences, arithmetic and geometric sequences. A sequence is a list of terms in a specific order. So there's a term 1, term 2, term 3, term 4, term 5, and so on. So here's a sequence, 7, 8, 9, 10, 11, 12, and so on. So there's two different types. There's an arithmetic sequence, and there is a geometric sequence. An arithmetic sequence has what's called a common difference. So to get from here to here, we're adding 2. And to get from here to here, we're adding 2. And every time to get from one term to the next, we are adding 2. Okay? And you can find that number by subtracting. Okay, so for example, 3 minus 1 is 2. And 5 minus 3 is 2. So that is called a common difference. So that 2 is the common difference. In a geometric sequence, to get from here to here, sure, we can add 2, but then to get from here to here, we're not adding 2 again. So we have to think of a different way to get from one to the next. 1 times 3 is 3, and 3 times 3 is 9, and 9 times 3 is 27. So this one, instead of being called a common difference, is called a common ratio. And you can find that by dividing. 3 divided by 1 is 3. 9 divided by 3 is 3. 27 divided by 3 is 9. Okay, so find the next 3 terms in this sequence. So we want to decide, do we have a common difference or do we have a common ratio? If it seems to change pretty evenly, it's probably a common difference. But if not, then maybe we have a common ratio, and if it's a common ratio, then it may appear to change drastically. Okay, so -5, 7, 19, it doesn't look like very drastic changes. I'm going to check for a common difference. So 7 minus -5. 7 minus -5 is 7 plus 5, and that is 12. Then I'm going to check the next set of numbers. So I did 7 minus -5. Now 19 minus 7. That's also 12. So that means 12 is the common difference. So that means I want to continue to add 12. So I've got 19 plus 12 is 31. Plus 12 is 43. Plus 12 is 55, so those are my next 3 terms, 31, 43, 55. 27, 135, 675, that doesn't look like it's changing evenly, so I'm going to check for a common ratio. 135 divided by 27, so that's term 2 divided by term 1 is 5. Okay, then I'm going to check the next 2 terms. So term 3 divided by term 2, 675 divided by 135. Got a typo in there, so I'm going to try that again. 675 divided by 135. And that is also 5. So that is a common ratio. So we're multiplying by 5. So 675 times 5 is 3375. Okay, so then times 5, and times 5 again gives me my next two terms, 16,875 and 84,375. Okay, so again, do we have a common difference or a common ratio? This 2 is the same as 2 over 1. So we need to decide what's happening in the numerator and what's happening in the denominator. It looks like the numerator might be multiplying by 4, the denominator multiplying by 3, so maybe 4/3 would be a common ratio. Another way to check that, term 2 divided by term 1, 8/3 divided by 2 over 1, and I can do an outer loop and get 8. Inner loop is 6. 8 over 6 simplifies to 4/3. And then I can do 32/9 divided by 8/3. 32 times 3 is 96. 9 times 8 is 72. And if I'm not sure how that simplifies, I can divide and then ask for it as a fraction. And it's 4/3. So it looks like I've got a common ratio of 4/3. So I'm multiplying the top by 4 and the bottom by 3. So 32 times 4. So I'm going to have 128 over something. And I'll just keep doing the tops. Times 4 and times 4. Okay, and then I'll do the denominators. 9 times 3 times 3 and times 3. And the last one here on this page looks more like a common difference. So -7 minus 5, that's -12. And then -19 minus -7. And minus negative means plus. -19 plus 7 is -12. So we've got a common difference of -12. So -19 plus -12, which is the same as -12. -12 again and again. And those are the next three terms. So to find a particular term in a sequence, an arithmetic sequence, a sub n, that means some particular term, equals the first term plus the common difference times n minus 1. So a sub n, that actually means the value of the nth term. So if we're talking about the 10th term, that would be a sub 10. It would be the value of the 10th term. A sub 1, that is the first term. D is the common difference. N is the position of the term. So if it's the 10th term, then n is 10. Here in a geometric sequence, a sub n is value of the nth term, just like it was in arithmetic. A sub 1 is the first term. N is the position of the term. The only thing that's different is there's an r, and that is the common ratio. So find the 68th term of this sequence, 16, 7, negative 2. So the 68th term, first that tells me n is 68. A sub 1, the first term, is 16. I have to decide if there's a common difference or a common ratio. It looks to me like a difference. So let's try 7 minus 16, negative 9. And negative 2 minus 7, that's also negative 9. So there's a common difference of negative 9. And we want to find the value of the 68th term. So we want to know what is the value of a sub 68. A sub 1, and because it's a common difference, I know I'm using the arithmetic sequence formula. So a sub 1, first term is 16. Plus the common difference, negative 9, times n, which is 68, minus 1. So 16 plus negative 9 times 67. So the value of the 68th term is negative 587. Okay, find the 14th term in this sequence. So n is going to be 14. A sub 1 is 1. Then I have to decide if there's a common difference or a common ratio. So it looks to me more like a ratio, so let's try dividing 1/3 divided by 1 is 1/3. 1/9 divided by 1/3. Outer loop is 3, inner loop is 9. And that simplifies to 1/3. So I've got a common ratio of 1/3. So the 14th term, a sub 14, equals, and I need to scroll back up a little to show the formula, a sub 1, which is 1, times r, which is 1/3, to the n minus 1 power. N is 14, so the 14 minus 1 power. So that can be simplified a little bit before I start putting it in the calculator. 1 times something isn't going to change anything. So it's 1/3 to the 13th power. So I want to clear that and put that in parentheses. 1/3 raised to the 13th power. And will that put that in a fraction for me? No. So let's do it this way. Let's do the numerator to the 13th power, and that's 1. And then let's do the denominator to the 13th power. So there is the value of term number 14. Okay, find the 29th term in this sequence. So n is going to be 29. Term 1 is 1.3. Then I have to decide if there's a common difference or a common ratio. 1.3, 3.9, 11.7. That's a bigger jump. So I'm going to say probably a common ratio. 3.9 divided by 1.3. And that's 3. 11.7 divided by 3.9. Let's see if that's the same. That is also 3. So I've got a common ratio of 3. Okay, so the 29th term would be a sub 1, so that's 1.3 times the common ratio, 3, to the n minus 1 power, 29 minus 1 power. The only simplifying I can do here is this subtraction is going to give me 28. I can't multiply these until after I've done the power. So I'm just going to put this in my calculator as it is, except I'll put in a 28. 1.3 times 3 to the 28th power. And I'm probably going to get scientific notation here. And we'll round it. 2.97 times 10 to the 13th power is our approximation. And then find the 20th term. So n is 20. For this sequence where the first term, a1, is 4, and looks like a common difference to me. 15 minus 4 is 11. 26 minus 15 is also 11. So it's got a common difference of 11. Okay, so a sub n, a sub 20, equals a1, so that's 4, plus common difference, 11, times n minus 1, so that's 20 minus 1. So that's 4 plus 11 times 19. Okay, so which really just means we're starting with 4 and we're adding the common difference 19 more times to get to the 20th term. And we get 213.